to Python Libraries 101, and today is our fourth session, and we'll be talking more about Python Standard Library. So to start off, let me introduce our team. So I am Shermaine, and I am an incoming EIE freshman at Imperial College London, and I am a Women Who Code Python volunteer. And Soumya, would you like to introduce yourself?
Yep. So hi everyone, welcome to the fourth session. I'm Soumya Vemuri, and I'm a final year undergraduate student pursuing my degree in computer science and engineering. Karen?
Thank you, Soumya. Hi, I'm Karen. I am a programmer in a research and development company. I am a lead of the Women Who Code Python, and I'm very excited to be learning. Would be like working on the libraries today with you guys. Back to you, Shermaine.
Thank you, Soumya and Karen. So I am the speaker for today, and you can connect with me on LinkedIn using this link, or you can just search for like Shermaine on LinkedIn. Yep. So let's start. So today's agenda, we'll recap a bit about what is the Python Standard Library, and then we'll move on to the modules that we'll be exploring today, which will be random module, math module, statistics module. Whoops. Okay, and then we'll move on to the setups and requirements, and then we'll move on to our hands-on coding. So a bit about the Python Standard Library. So what is the standard library? So Python offers a lot of built-in functionality through its standard library. Built-in modules are written in C and integrated with the Python shell. The standard library is a huge collection of utilities ranging from math utilities to debugging to creating graphical user interfaces. And these are the popularly used modules. And we've already covered a few of them, and we'll be covering more throughout our series. So now we will start off with our first module for today, which is the random module. So more about it. So it's a built-in Python module, so you don't have to like download it separately. You can just import it using this syntax import random. So this module implements pseudo-random number generators for various distributions. So let's look into the different functions in this module. So firstly, we have random.seed, and then you can put in a number here at n, which initializes the random number generator. So what this does is it's used to save the state of a random function so that it can generate same random numbers on multiple executions of the code on the same machine or on different machines. So this may be quite confusing right now, but we'll try it on later and you'll understand it better. So what's the use of this? It's to make optimization of codes easier, where random numbers are used for testing. So this seed function is used to generate some same random numbers again and again and again, and it simplifies algorithm testing process. So let's move on to other functions. So we have random.randRange, and you can put in 3 different things in here. So you have the start, stop, and step. The start and the step they are like optionals. So the stop is like the compulsory one. So what this function does is to return a random number between the given range. So the start is the starting point of the range, and this would be included. Stop would be the stop point, and this would be excluded. And lastly, step would be steps to be added in a number to decide a random number. So for example, if you want to generate a number from 0 to 10, then you'll put 0 as your start and 10 as your stop. But then you only want numbers like in multiples of 2. So your step would be 2. So it will only generate like 2, 4, 6, 8, 10. Yeah. So next one, we have random.randint, and this one would be just 2 numbers inside. So this returns a random number between a given range, including the starting term and the last term. So it's different from the rand range because the rand range, the last term is not included. Next, we have random.choice, and then you can put a sequence. And this returns a randomly selected element from the specified sequence. So it can be a string, a range, a list, or like any kind of sequence. So next we have random.shuffle, and it returns the sequence in a random order. So like similarly to the random.choice, you can put in any kind of sequence. And next you have random.random, which returns a random float number between 0 and 1. But then if you want like a float number above 1, you can use random.uniform, and then you have to put like your start and your stop term. So it will return a random float number between the two given parameters. So next we'll move on to the math module. So the Python has a built-in module that you can use for mathematical tasks. So similarly to the random module, you don't have to like download it separately. So all you have to do is to type in import math. And this math module has a set of methods and constants that we'll be looking at. So these functions are available. So these are like related to trigonometry. So you can actually return the arc cosine of a number in radians. Most of them are in radians. So they are like arc cosine, arc sine, arc tangent. And then you also have like cosine, hyperbolic cosine of a number. And you actually also have tangent and sine, but I didn't put it in here, but you can just change your cos to sine or tangent, and it works the same way. And next thing, it also has these two functions where it helps you to convert an angle from radians to degrees. So if you want to change from radians to degrees, you put math.degrees and then put in the radians in between the parentheses. And then if you want to change it the other way, then it will be math.radians. Next, math.ceil, which is like short form for ceiling. And then if you want to round it down, then you'll be using math.floor. Next, you have some functions here that help you like with your operations and all that. So you have math.fmod, which returns the remainder of x divided by y. So it's the first number divided by the second number. Next, you have math.fsum, and in your parentheses, you put a list or like any kind of iterable. And what it does, it returns the sum of all items inside. Next, you have math.trunc, like truncate. And what it does, it returns the truncated integer parts of a number. Next up, you have math.exp. And then what it does, it just returns e raised to the power of x. So you don't have to like type it out manually. You can just use this. You can just use this function. Next, you can use math.facts, which returns the absolute value of a number. And lastly, you have math.factorial, which returns the factorial of a number. So we move on to our last module for today before we move on to hands-on coding. So the last module is statistics module. So once again, this is a built-in module in Python that you can use to calculate mathematical statistics of numeric data. And you can just use import statistics to get it imported. So the functions, oops, I forgot to change this. Anyways, so you have different functions such as statistics mean, and it calculates the mean or the average of the given data. So you can put it in a list and it calculates the mean for you. And next, you have statistics median, which calculates the median, which is the middle value of the given data. So sometimes when you have like a list of data, right, you have, let's say, an even number of data. So you can't actually find, you want to like find what's the middle data, but then it will give you like a decimal place because you have even number of data. So that's why they also have like median underscore high, which calculates the high median of the given data. So if the number of data values is odd, it returns the exact middle value. But if the number of data values is even, it returns the larger of the two middle values. And you'll get to see this later during our hands-on coding part. So, oops. So you also have statistics.median underscore low, which is just the opposite of median underscore high. So this calculates the low median of the given data. Other than that, you have statistics.mode, which calculates the mode, which is the central tendency of the given numeric or nominal data. Next up, you have statistics.stdef, which is calculating the standard deviation from a sample of data. And lastly, you have statistics.variance, which calculates the variance from a sample of data. So with that, does anyone have any questions? Feel free to drop your questions in the Q&A section. Okay, seems like everyone is doing fine so far.
Looks like it's good so far, yes.
That's great. Okay, then we'll move on to our coding part. Can you all send the collab link? Thank you. Yep, so Soumya has sent the link. So what you can do is you go to that link. Okay, let me go to that. So you can go to that link, click File, and then click Save a Copy in Drive, and you get to have a copy in your drive. And you can just edit it all however you want. So go to the link Soumya sent and click Save a Copy in Drive. Do you give me a thumbs up or a B once you're done so that I know that, yep, once you're all set to go. Yeah. Looks good. Okay, then we'll begin. So firstly, you'll want to click connect. So you just wait for it to connect. It will take some time. Okay, it says connected. Woohoo. Okay, so we'll move on to the coding part now. So firstly, we'll look at random module. Let me just zoom in a bit. Okay, does this look okay? Is it big enough?
Yep, it's
Yes.
good.
Okay, that's good. So we'll first need to import the random module. So you don't need to install it separately. So you just run it, done. Okay, then now we look into the functions of random module. So we'll look into random.seed, random.ranInt, and random.ranRange. So like we said earlier, random.seed initializes the random number generator, causing the same number to be generated. So let's try initializing with a 1 and then printing a random number from 0 to 10 inclusive. So we run this and it prints out 2. And then if we run it again, because we use the random.seed 1, it always ends up printing a 2. So this is how you use it. So you can always change this number to whatever you want and it will just change it. But then if you run it again, it will still continue generating the same number. So it can be used when you want to like let someone else use your code, but then you want like the number generated to be exactly the same. So you can always use this function. So next up, we have random.ranRange, which returns a number between the given range, including the starting term, but excluding the last term. So we run this. So it gives you a 2, but then because we didn't use random.seed, whoops. So it ends up always generating a different number. See, it keeps generating a different number. Next, we use the same thing, random.ranRange, but then we put a parameter in for the step. So we put 2. So what this means is it will generate a number between 0 and 10, but then in steps of 2. So we run it and there will be 4. We run it again, it'll be 8. So it's always in multiples of 2. So that's how it works. And lastly, we will try random.ranInt, which returns a random number between the given range, including both the starting and the last term. Ta-da! So you can always just change your parameters like from 30 to 100, something like that. Ta-da! So just generate a random number for you. Yay! Okay, so now let's try something. Generate 3 random integers between 100 and 999, does not include endpoints, which is divisible by 5. So since you want to generate 3 random integers, we'll start off with for I in range 3, so that this will keep going on for 3 times exactly. And then what will we write in here? We will write random because you want it to be divisible by 5, so you need the steps parameter, so you'll use range. And then because you want between 100 and 999 does not include endpoints, so your starting term, since it includes the starting term, hence it should start with 101. And since it excludes the last term, so you can put 999 and then you put steps, which is 5. And with that, you should be good to go, and then you can run it and it will give you 3 random integers. So just keep generating 3 different random integers between 100 and wait. Oh, this is not divisible by 5 because you start from 101, so it will be plus 5, which will go to 106. So you should start with 105 instead. Ta-da! Okay, now it works. So now it's all divisible by 5. Yay! Okay, so that is range, int, and random.seed. Okay, now we move on to random.choice and random.shuffle. So we'll just give this a random string, and what it will do is to generate a random letter in this string. Oh, so it generated O. So you just keep generating different kinds of, oh, now it generated the spacing. So it just chooses one of the characters in this string. Next, we try out random.shuffle. So my list would be A, B, C, D, E, F. You can put anything you want actually. Then you randomly shuffle it. You shuffle this list and then you print out the list and see how it looks like after that. So you know at the start it looks like A, B, C, D, E, F. So now let's run it and see how it looks like. So now it's F, A, C, B, D. And if you run it again, then it'll just keep changing. Woo! Yeah, okay. So now let's try something new. So I want you to shuffle the list of names. So I just added all names and then pick a random name from the list. So this is the current list of names. So I have Soumya, Karen, Shermaine, Mary, Amber, Stephanie, Archana. But then I want you to first shuffle this list of names. So what you should do is random.shuffle. And then you put in the name of the list of names, and then pick a random name from the list. So print random.choice, then you put the name of the list. So this should work. So what it does is it shuffles the list, and then it chooses a random name in your shuffled list. So let's run it. Oh, so it generated Stephanie, who isn't here with us today. Okay, let's shuffle again. Okay, then we chose Mary. Ooh, Karen. Yep, so this is how it works. Okay, now let's try something else again. So now I want you to roll the dice 5 times, but in a way that every time you roll, you get the same number. So remember at the start, we learned random.seed, which helps you generate the same thing over and over again. So this is what you have to use in this scenario. So a dice would have 1, 2, 3, 4, 5, 6. So I put it in a list. And then I'm randomly selecting the same number of a die. So I want to roll it 5 times, which is why I put for I in range 5, so that it goes 5 times. So now let's write our code here. So remember to initialize your random number generator by using random.seed, and then you can put a random number. I want to put 2. Then you want to get a number. So you'll be random dot choice from your dice. So this should work. Let's see. Oh wait, I need to print it. Whoops. Ta-da! It ends up generating the same number again and again. And if I run it again, it will still give me 1. So I can change this number to, let's say, 9. And it will give me the same number, another number, but it will keep generating the same one. So that's how random.seed works. So if we remove this random.seed, so let me just comment it out. What happens is it will keep generating a different number. Oh, seems like they generated 3 and 2 times. Okay, but that's just random. So ta-da! Ooh, all 5 different numbers. Yep, so this is how it works. So if you put in your random.seed back in, it will end up generating the same number for 5 times. Okay, so let's move on to our last 2 functions for random. So we have random.random, which returns a random float number between 0 and 1. So let's run this. So it just gives you a random float number between 0 and 1. Let's try again. Gives you another float number. Okay, but then if I want a random float number above 1, so I want it between 2 and 5. So I use random.uniform and I put the 2 numbers in here. And ta-da, it gives you a random float number between 2 and 5. So let's try again. Gives you another random float number. Okay, so let's try now. Calculate multiplication of 2 random float numbers. So let's just use random.random. So we just generate a random float number between 0 and 1. So random.random, and then the second one, same thing. And print out the first number times the second number. Okay, so let's just take a look at what was generated. Okay, let's just put it clearly. Number 1. And then number 2. Okay, so the first number it generated was 0.604, blah, 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 blah. Second number, 0.33, blah, 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 blah. So when you times it together, it gives you this. So you run it again and see how it changes. So it once again generates a random float number between 0 and 1, 0 and 1, and then it multiplies them together. Okay, is everyone doing good so far? Let me just check the chat.
We have a couple of questions on the Q&A, yeah.
Okay, let me just check it out. For random.seed, it doesn't matter what number you put in. It doesn't matter actually. So, okay, let's just go back to the first one. Where is it? So let's say you put 4. Actually, I don't know how big a number you can go. Let's just try. Oh, see, it just generates a random number. So it actually doesn't matter as long as if you want to pass on this code to someone else, just make sure that you use the same number in your in between the brackets so that it will generate the same number out. I hope this answers the question. Okay, next. Is random.uniform inclusive of endpoints unlike random.random or random.range? The thing is, because it returns a random float number between the 2 given parameters, and usually you wouldn't put a float number, you wouldn't put so many decimal places in this. So it's actually exclusive of the endpoints because usually you'll put an integer, or even if you want to put something with some decimal points, you wouldn't put it so long. So for example, like this. So once again, it will generate something that is exclusive of the two endpoints. Yep. Okay. Does random.random only do a number between 0 and 1? Yes, it only returns a random float number between 0 and 1. So if you want something more than 1, then you have to use random.uniform. Did I miss out anything? We could have just used a single number and printed it instead of creating a list of numbers and selecting same number every time by setting a seed. Could you please elaborate some practical applications of this approach? Because like you really want it to be randomized instead of like, oh, I want the number 2. So you really want to make sure that it's as randomized as possible. That's why you use random.seed. Practical applications. Let me think. Yeah. Okay, so for example, in like machine learning, if you have like a huge data set and you want to like split it randomly into training, validation, and testing sets, right? So you want to like split it in such a way that you know how it's split. That's why you use random.seed, and then you randomly split it apart. And if you want like a different person to use like your code and have like similar results, you will want them to use random.seed as well, so that your data set will be split the exact same way as what you did. I hope this helps.
Yep, and also for so if suppose you want to test your code, but you need a random input for that, but if you want to test it out again, you will need that number, right? So if you use random.seed, you can test it over again using that. When you do need a random number, but there are chances that your code might need to use a number again. So that would be one other use. And I think it could also be used when you're using encryption. So in cryptography, if you have key encryptions, then that would be another place where you would need seed. So even if random is a module where you need random numbers, sometimes you do need to use it again. So yeah. So it's just like some other stuff, right? So if you're using a tuple and a tuple's functionality is that you can't add more elements once it's created, but at some point you will need to extend it. So you'll try to concatenate two tuples. So even if that's out of the scope of the functionality of it, you will have a case where you need to have something that it doesn't allow. So yeah.
Okay, I think I can move on, right? Okay, so does anyone else have any more questions regarding the random module? If not, I will move on to the math module. Okay. Okay, so with that, we will run our math module. So import math, so just run it. And then we look at the functions. So conversion between radians and degrees. So math.degrees, and then I just put in like the numbers of pi. So it should actually give you 180. So let's just divide it by 2, and it should give you 90. So this is how this function works, and then converts it the other way around, math.radian. So this converts degree to radian. So there you go. So just put a random degree, and it returns you the radians, the answer in radians. Yep. So now we look at the rounding off. So just now we saw math.ceil, which is ceiling for short, and then we saw math.floor. So let's see. So actually it's not a very good example. So 0.4. So usually when we round this off, we will get like, if we round this off to a nearest integer, we'll get 0. But then because we use math.ceil, so it will round a number up to the nearest integer, which will be 1. And then if you use math.floor, once again, if you round 2.8 to the nearest integer, usually you'll get 3. But because you use math.floor, so you end up getting 2 instead. So now we look at some operators. So f mod returns the remainder of first number divided by second number. So 3 divided by 2 would actually give you a remainder of 1. So this should give you 1. So I mean, you will usually use like a bigger number for this. And like, yeah, something like this. Ta-da! It's actually 185. Okay, so now we try math.fsum. What it does is it returns the sum of all items in this list, which is 4327. Well, usually when you use this function, you have like a larger data in your list. So you wouldn't want to like calculate it manually. So that's why you use this function. So 4 plus 3 plus 2 plus 7, which give you 16. So you can just add like many, many numbers. Whoa. Okay. Yep, so it gets you 515.0. So let's say we put like that. And it still works. So it just adds them all up. So you don't have to do it yourself. Okay, so this math.trunc, what it does is it returns the truncated integer parts of a number. So this one would just like cut off this part. 2, 3. Yeah, there you go. Next, we have math.exp. So it's e raised to the power of your number here. So this would give you e to the power of 2, so e squared. So you get your answer here. And then you have math.fetch, which returns the absolute value of a number. So it would just be 1, 2, 3. Then you have factorial of a number. So it'll be 5 times 4 times 3 times 2 times 1. Ta-da! So you can just use any number you want. Oh, wow. Yep, there you go. Okay, great. Okay, and that's it for the math module. It's actually quite straightforward for the math module. Does anyone need any help? What if we want to use these packages? Oh, Soumya's typing in. All right, thanks, Soumya. Wait. What do you mean power equals factorial? Hmm? Wait, what? I'm very confused. And Sonia, you said, so those need brackets and not parentheses. Which one are you referring to? So for factorial is like 5 times 4 times 3 times 2 times 1. So let's just change this to 4. So it will give you 4 times 3 times 2 times 1. So that's factorial. So it's different from like power. Does that answer your question? I'm not really sure what you're asking actually. What is a factor exactly for math.factorial? So this number here, it just tells you like what is just what. So it's like factorial of a number. So 4, it will be 4 times 3 times 2 times 1. So if we change this to 6, it will be 6 times 5 times 4 times 3 times 2 times 1. So that's what this number does. Yep. Does that answer what this function does? Hope it does. Okay, could you wait, someone asked, could you please repeat one more time, why do we use seed? So we use seed because we want to keep generating the same number. So what this is usually used for is when you want to, like, let's say, for me, I use it like when I want to like keep generating the same number, because usually when I use random, I want to like get the same number back instead of just like getting random numbers that I keep getting different outcomes, which makes me very confused. And the first time I actually saw random.c was like in a tutorial. So the person explained why they use that was because it's to help guide the students better, so that when we run our code and we see our output, it's actually the same as our teacher. So it actually helps us better to see that our code actually works. So that's like one application why you use seed. Yep.
There's a question about brackets. Could you go to that part once?
Wait,
I think it's the box brackets.
Here?
Uh-huh.
So for list, like we use the square brackets, which is like to represent your list. So what it does is, wait, let me look at the question again. Why are there brackets there? As in, why there are square brackets here? So what this does is I'm naming this list as LST, and I use the square brackets to represent the numbers inside the list. So I created this list such that when I use this function, it will return the sum of all the items inside this list. So in order to have a list, you have to use your square brackets instead of like your normal rounded brackets. Yep. I hope that answers your question. If you still don't understand, you can drop your questions in the Q&A section. Yay, okay, solved. Woohoo. Yep, what Soumya said. Okay,
yeah, I mean,
I
just type it there for reference as well.
Okay. Okay, with that, we'll move on to the last module, which is statistics module. So same thing, you import this module, import statistics, done. So once again, I created a new list. So that's why I use the square bracket to create this list. So I just create it first because I'll be using it in the next few functions. So statistics.mean, and then I put in my list that I created earlier. So what this does is it calculates the average or the mean of the given data, which is 1, 23, 5, 6, blah, 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 blah. So when I run this, it will give me the mean, which is 40.7. So instead of having to add all these yourself and then dividing by the number of terms, you can just use this function here and it helps you do it straight away. Next, we look at the calculation of the median, which is the middle value of the given data. So it's 15.5. So it's not like, okay, let me just continue and I'll explain it later. So after we use statistics median underscore high, so it actually gives you one of the numbers here. And then if you go to statistics median underscore low, it actually also gives you one of the values in this list. So how we actually calculated the median in the second line of code that we ran was 23 plus 8 divided by 2. So it actually gives you the exact middle of the date of the given data, but it actually doesn't give you like one of the numbers in this list. So why this happens, because you have even number of numbers in this list, which is why they had 23 and 8 as like the middle, but then that's not exactly the middle, so they had to add it together and divide it. But then if you want like the exact number, so you have to use median underscore high or median underscore low to find out what is the exact two numbers that like are sharing the middle. So I hope this explains what median underscore high and median underscore low does. Okay, moving on, then we look at statistics dot mode. So if we look at it, you realize that there's two 100. So this should give you that. Yay, it gives you 100. So it just tells you which one appears the most often. And we now can calculate the standard deviation from a sample of data, so the same data. So instead of having to like do manual calculations again, you can use this function. Ta-da! So it just gives it to you. And lastly, we have statistics.variance, which helps you calculate your variance instead of having to do it yourself. Yay! So it's like very neat. You can just run it and it tells you straight away instead of having to like punch into your calculator. Okay, so someone asked me to explain median underscore high and median underscore low again. Okay, so let me go back to that. Okay, so we first look at our data here. So median is your middle value, right? So, okay, let me just arrange this nicely so that it's easier to see. 23, 34. Okay, now that looks better. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 terms. So your middle value, you don't actually have an exact middle value since it's even number, right? So it will be between 5 and the 5th and the 6th term, which is 1, 2, 3, 4, 5, 6. So it will be 8 and 23. So what the median does is to calculate the middle value, which is, since it's shared between these two, it will give you 8 plus 23 divided by 2, which gives you 15.5. So what median underscore high does is to give you the high median of the given data. So because these two share the middle value, so it will give you the higher value, which is 23 in this case. So it will give you 23. And then median underscore low would give you the lower one, which will give you 8 in this case. However, if you have like odd number of data, which will give you then like an exact middle value, then okay, let's just try it. Okay. So it will then give you the same for median underscore high, and median underscore low. So it just gives you the same thing. But then if you unfortunately have like even number of data, then you want to like use this to figure out which two numbers are like sharing the middle term. I hope that answers. Yeah, that answers Amber's question as well. So if you have odd number of values, it would give you the same value. Yep. Okay, seems like that's it, right? If everyone's good, can you give me a B or a thumbs up? Yay. That's a lot of B. All right. Okay. And there aren't any more questions in the Q&A. Okay, and with that, it's like the end of the session, actually. So let's just go back to the slides. So, oops. So here are some useful, okay, hold on, it's loading. Okay, so here are some useful links. So you have these three, which helps you like look at the different functions that these three modules actually give you, and other resources as well. So you can actually find these slides in our Git repo, which was sent in the chat earlier. So you can just go to the slides, click on the links to learn more about these modules. And also, is it lagging? Okay, so remember to stay connected with us. Join us on social media at this social media handle, www.python. You can find us on Instagram, Twitter, and LinkedIn, and our upcoming event in the series. So just a slight change. There wouldn't be a session next week, but so our next session would be 28 August. And at the same time, it'll be recap, Q&A, and repeats in Python Standard Library. So we're going through whatever we did in the past 4 sessions. So feel free to come, and remember, it's not next week, it's on 28 August. And then after that, we will have another session for September about data visualization and many, many more to come. So we hope to see all of you at our future sessions. Yay!
We'll also have regex in the recap session. So we'll have regex done by Karen, and then it'll be followed by a small recap for anyone that wants a short summary of whatever we covered. And we'll be closing Python Standard Library with that.
Yep. And also we have upcoming events in Women Who Code Python track. So we also have beginner Python study groups. So if you're new to Python, feel free to join us. And then we also have like many other events. So you can you can register for all these events in the link. And with that, thank you so much for joining us today. And I hope you've learned something new. And do remember to join us on our Slack channel. And then after you click the link, join #Python libraries. Yep. Thank you everyone for coming.